Tonight we will have Dr. Ludovic Ferriere from the Natural History Museum Abu Dhabi coming on stage and telling us about his knowledge, everything about meteorites. Dr. Ludovic Ferriere is a French geologist, another French, two French on stage tonight. Expert on meteorites and impact craters. But again, I will let him introduce himself and tell us all about impact craters, meteorites, and so on. Just a quick remember before I leave the stage and let Dr. Ferriere start his talk. Just remember to not go in and out the room, to keep quiet, and to put your phone on silence. Keep your question for the end. We will take our time at the end to answer all the questions you have. I'm sure Ludovic will tell all the cool facts about his work and so on, but I just want to say, and I hope I'm not saying something that you will have a surprise later on, but he has an asteroid named after him. How cool that is, really. There is an asteroid over there in space called Ludovic Ferriere. Amazing. All right, come on stage, Ludovic.
Thank you. Does it work? Do you hear me? Thank you, Alice, for the introduction, and thank you for mentioning the asteroid, because it's not part of my presentation, but yeah, I do have an asteroid that it's 5 kilometers in diameter that is orbiting somewhere, and but it will never impact the Earth. Today we will look at things that do fall on Earth. That's why I did not include my asteroid. I mean, I'm not owning it, it just has my name. I will cover two topics. I will start my presentation with meteorites, and I will then dive you to the impact craters and take you with me in some of my journey, some expedition that I did in the past. Now, since 8 months, I started an amazing job here at the Natural History Museum Abu Dhabi that you have probably seen. It's growing up, and we hope to open it to the public by the end of next year. And I will start the journey just to give you a bit of background. I'm French, born in France, coming from the countryside and exploring all around my place. It's a very tiny village where I was collecting fossils, rocks, all what I could find. And I have been all the time interested by natural history and connected with the sky, because I had the chance there to have very beautiful sky, to see stars and of course the moon. And one day I found this rock that I found a bit odd, and I collected it, and I was convinced myself that I found a meteorite. And I will already tell you, it turned out that I found myself what it was after some years. It was a slag. It's an industrial product. It's what is mostly confused by people as being meteorites, because they look very different from the environment, and they are heavy, they could be magnetic, and it turned out that my first meteorite was a meteorite at the time. Before to arrive in Abu Dhabi, I had a very long journey. I mean, I went up to a PhD, postdoctorate, and so on, and I ended up at the Natural History Museum Vienna, that you can see on the upper left, an amazing natural history museum where I've been working for 13 years as curator of the rock collection and of the meteorite collection. I totally renovated this hall that you see there. That is the world's largest exhibition of meteorites. I'm inviting you to stop by there if you visit Vienna. And I'm still associate scientist at the museum there. And why I'm mentioning that is because in the duty as curator here in Abu Dhabi, and as my colleagues, we are working with colleagues internationally. Just before to get you to the meteorites, I want just to explain you what is a curator, because it's a bit, yeah, I managed to put 4 pictures of myself on this slide. Usually I'm saying it's a straight job for the price of half one, but you do it because you are passionate, usually, and it consists of what you would imagine a curator is doing is taking care of the collection, putting together exhibition, trying to grow the collection, Yeah, even cutting meteorites in the upper pictures, trying to get donation. This is a quite nice donation here of a meteorite from Cuba with the son of Fidel Castro and a famous actress over there on the top, Isabelle Huppert, that allowed me to buy a moon piece and so on. It's why this is the first part of the job. Second part of the job, it's to do science. We are sometimes deep in our laboratory trying to discover something. Here I just put some of those. We are also scientists. And what I like a lot is interacting with the public, with the media. I think it's very important to share. Even we have little knowledge, it's nice to share it with the various audience. So I'm very happy tonight to see that there is a very young public, a bit older in the front. They are my colleagues from the museum, so I'm just teasing. And we have the chance as curator to meet really important people, really inspiring people. Like here you see the director of NASA, holding the book that I wrote, one in Vienna, the director of OPEC, and really a lot of people, and especially meteorite, it's really something that talk to everybody. But tonight I will try to tell you the story that they bring to scientists. And the last component that is one of my favorite is expedition. I really love to be in the field, and I'm going to tell you in the second part of my presentation about at least one of my most successful expeditions. This was what a curator is doing. These days at the Natural History Museum Abu Dhabi, we are focusing on the museum. It's why all these aspects are a bit on the background for the moment, but we are putting together hopefully something amazing, and hopefully you will visit it by the end of next year when we will open. Let's go to the meteorites. I will go through some definition and things just to put everybody on the same scale. Meteorites, you see different pictures of meteorites. They are all cut, and you can see that for many people, meteorite is ugly, it's black things, but you see, if you start to cut them and look at the inside, it's like people. You have wonderful things if you start to look with another perspectives. But here, meteorites. Meteorites, the definition, I mean, there's many definitions, but what I think is quite understandable, it's a rock. They are made of rock or iron metal, extraterrestrial in origin, and they would survive to the entry in the atmosphere and safely land on the ground. So a meteorite is the rock that you will collect on the ground. When you see something in the air, it's not a meteorite. The meteorite is really the object that you can collect to the ground. What you may have seen is a meteor, a fireball, or a shooting star. I hope everyone in the room have seen a shooting star. Who have not seen a shooting star? If you have not seen a shooting star, there is actually right now a meteorite shower. It's why you just go out, go a bit further away, because here there is a light pollution, but go in the desert, you can see shooting star every single day. There is 100 tons of material coming to the atmosphere every day. That's why there is a lot of it that is just going through the atmosphere, and it's like grains, sand grains that are disintegrated. And this, what you see, this phenomenon is called a shooting star when it's a tiny grain and completely consumed in the atmosphere. When it's something more bright, it can be, if it's happened in the night, it can be day in the night for some seconds when this stone is crossing the atmosphere. This is basically, your stone is coming with a cosmic speed of about 20 kilometers per second, 70,000 kilometers per hour. You can calculate that, guys, later on if you want to check if the numbers are good. And it's slowing down in the atmosphere. At 100 kilometer altitude, it starts to be bright because it's interacting with the atmosphere, ionizing the air, and it slows down. And at about 20 kilometer altitude, it's finished. You don't see anything. It's what we call the black fly. Why you don't see the last 20 kilometers, and when it's collide with the ground, it's just a free fall. So if you would jump from an airplane, it's a little bit more than 200 kilometers per hour. So it's a soft landing. This I'm talking about small stone. Later on, I will tell you about bigger things that don't care about the atmosphere and that will just impact with their cosmic speed and make a big hole, an impact crater. You know, scientists, they like to classify things. That's why don't be afraid and don't leave, because I have a surprise for you later on. But this is kind of a simplified classification of meteorites. Just to, you know, like every expert will try to put things in a box. And here is to show you the variety of type of meteorite that there is. But I simplify this in 4 types of meteorites. for everybody to understand. There is these 4 big types of meteorite, and I think it's quite obvious when you see them that they are different. You will see on some of my pictures, normally most of the pictures I'm presenting are from myself, so I don't put any credit. If there is credit, it's somebody else did it. And there is a scale bar. This is especially for the kids. I'm already answering the question. Sometimes there is a coin or there is something. It's just to know the size of the object, because you will see meteorite can be very big, and if I don't put a scale, like here is written 1 centimeter, or there is a small cube, sometimes I put a coin, it's just to give an idea of the size. The first type of meteorite, the more common one, the more primitive one, we call them chondrites. They are stone meteorites, and you will see that they are, when we cut them, there is a black surface, what we call the fusion crust, that is formed during the atmospheric entry, but the inside is pristine. You have to imagine when your rock is coming, it's getting hot at the surface, it's melting like the very top surface, but the rest is pristine. You have to imagine that these rocks that you see here is 4.5 billion years old, the age of the solar system. And they are derived from asteroids, like the one you can see on this image. This one, if we study them, we understand the very early days of our solar system. And if you look at the microscope, these things is like art. I could have displayed that at the art fair right now in Abu Dhabi. These are thin sections. You know, we cut them and we look at them through the microscope. You see the scale bar is 200 micrometer. To give you an idea, like the picture is about 1 millimeter, in fact, in size. And you see all these small spheres that are called chondrules. This is why we call this meteorite chondrite. And they are unique to meteorites. And they are quite fascinating in terms of color here, because I use a polarization on the microscope, allowing you to see all these colors that are due to the different minerals, because they are composed of different minerals. Most of these minerals, we find them on Earth. Some we don't, and I will come back to that a bit later. Then there is the other type of meteorites, the iron meteorite. You see a picture over there. These they are made of really of iron nickel, and in this case it was cut. You will see a lot of the meteorite I'm showing you are cut, because you can see much better the texture when they are cut. And this one is even etched with acids that show the internal structure, because it's not just a piece of iron, it's crystallized iron. And these meteorites, they come from asteroids that were big enough to make like the Earth. You know, the Earth where we live on the crust, but there is a mantle and a core. And this is a so-called differentiation process. And it's quite clear on Earth this happened, but there have been some asteroids that were big enough to exactly go through the same process. And due to collisions, they have been exploded in some pieces. And sometimes we receive a meteorite from the core of this asteroid. It's an iron meteorite. Sometimes from the mantle, it will be the next meteorite I'm telling you about, and so on. It's why, by looking at this meteorite in particular, by analogy, we can better understand how the core of the Earth is formed. By looking at these rocks from space, we better understand our own Earth, because we don't have a direct access of sample from our core. Then there is some meteorite that we believe are coming more from the transition between core and mantle. Even so, there is still a lot of question about their origin, and it's still very debated. And you see on the image on the upper right, they are made of a mixture of metal, iron, nickel, metal, and some grains that are greenish, brownish, so-called olivine. It's a silicate that we find on Earth, on the mantle, and at the surface when this reaches the surface. And these are so-called pallasite, and they are also differentiated meteorites. They are the most, the people love them because they are very nice. When you have thin slides and you put light through it, it's fabulous. I call them gemstones. They are even used for jewelry, those ones. And I all the time say it's not a very good present to give a meteorite to somebody to hold it as a piece of jewelry because of the nickel in there. There is a lot of people allergic to nickel. Well, only if you don't like your stepmother, you can offer a piece of jewelry like that, but I would not recommend. All these meteorites are coming from asteroids. As I mentioned before, and asteroids, they are like big potatoes that are orbiting around the sun. They have different size from a few meters up to hundreds of kilometers. And you can see already, I'm introducing the next topic, they are all covered of small holes. They are impact craters, because in this case, there is no atmosphere. That's why every collision with asteroids will create a new impact crater at the surface of these asteroids. This asteroid, most of them, they are orbiting between Mars and Jupiter. You can see some of them here. There is the most meteorites that we get on Earth are from this asteroid belt. There is a few other meteorites that are very interesting and that I like in particular, is meteorites that would come from Mars. The thing that I'm holding in my hand here on this picture, it's about 900 grams of Mars. What happens is you have an impact on the surface of Mars. If it's a strong impact in Mars and the energy is there, you could eject a piece of rocks from Mars, and then it will go into space, and during its journey, it may reach Earth if it crosses the orbit, survive to the entry to the atmosphere, and then you can collect a rock from Mars. And these are very rare type of meteorite, but very interesting, because on Mars we have some rovers, even the UAE have been organizing missions, a HOPE mission there, and you know, as a scientist we need a sample in the lab. It's why it's very complementary to have this meteorite from Mars that fall and arrive for free to Earth. They don't arrive for free to the laboratory, but at least they land for free. And then you can investigate them in details and better understand what is going on Mars. You will probably ask, how do I know that they are coming from Mars? It's not written made in Mars if you look at them in the back. In fact, we are sure at 99.9%, we found inside them gas, and this gas, when we analyze it, that gas that have been trapped, it's exactly the same ratio like the gas that have been analyzed at the surface of Mars in the early 1970s. This is an argument. The chemistry also is compatible. It's why we are sure at 99.9%. And as soon as we will bring some pieces of Mars back to Earth with a robotic mission, we will be able to say for sure at 100%. Then there is another type of meteorite that comes from the moon. This, for example, is a meteorite that probably some of you have seen already. If you have not seen it yet, it's on display at the Louvre right now. It's the only meteorite from our collection that I'm showing during this presentation. But you can see it at the Louvre, and then when we will open our museum, it will be featured there. It's 13.5 kilo of the moon. In this case, what happens? There was an impact on the moon, strong enough to eject some material from the moon. This piece has been orbiting in the solar system for a long, long time, thousands of years, and one day it crossed the atmosphere, it survived to the entry, it landed in the ground, and it has been recognized as a meteorite. These meteorites are also very, very rare, but very interesting for scientists. And I will invite you to stay until the end of my talk, because I took with me a piece of the moon, quite a large one, that you will be able to touch at the end with your finger. I will take it out of the box, where you will touch the moon and probably never see again the moon the same way, because I think it's quite unique to be able to touch the moon, or even to hold the moon. Good. I'm interested by the moon in particular because when I was in Vienna, I was trying to get some of the specimens for the collection and to do science. And this one, to make the story short, it was very hard to get this small piece, but I managed to get this small piece for the collection. And in these meteorites, I found this mineral. It's very tiny needles of minerals. You see the scale bar on the lower right part, 10 micrometer, 0.01 millimeter. And this mineral, when we analyze it with colleagues, we found out that it does not correspond to any known minerals. It's why we discovered a new mineral on the moon. And we had the chance, here you see the formula. It's made of calcium, aluminum, silicium, and oxygen, very basic formula. And we were able to give a name. We named it Don Wilhelmsite, after a famous geologist from the US. And what is very amazing in this case is that this mineral was the first time it was described. It's why we could get a name to it, but we found out that it's probably representing about 10% of the mineral we have in the mantle. It was never collected, but now we have it in a meteorite. This is why by looking at meteorite from the moon, we better understand what is happening below foot. Meteorites. There is different type of meteorite. There is fall and fine. You will say, okay, wait a minute. They all fall, right? But many of them, we don't witness the fall. And it's why we call them fine. It's why if you go in the desert in the weekend and find a meteorite, you don't know when it landed on the ground. It could have been landing like thousands of years ago. It's why this is what we call a found. For us scientists, the more interesting are the so-called fall, because they are normally recovered quickly after they arrive on Earth, and why they are more pristine, not contaminated. It's a little bit, I call it like the space mission for the poor guys. And in the total amount of meteorite we know, at the moment we know about 83,000 different meteorites. There is only 1,252 of them that are so-called falls. and they can be from a few grams up to several tons. This one that you can see on this image is 60 tons. It's the biggest, largest, heaviest meteorite that we know on Earth. Just to give you an idea of the scale, this is me on top of it. It's in Namibia. It's still there. Nobody tried to take it. We will not have it in our museum. It's part of the patrimony of Namibia. I really recommend you to go there. And you can be a bit confused. The things around it have been digged out. It's not an impact crater, you know. If it would have made an impact crater, the meteorite will have blown up. But this we will discuss that later on. Meteorites are fantastic because, you know, you look at it like this, it's a bit ugly, there's these black things around. This one is a very special fall. It fell in 1969 in Mexico. It's called Allende. And if you start to look inside, it contains really amazing diversity of things, like a potpourri. And you see the white spot in there. These are the oldest objects that we can date back to get the age of the solar system. There are specific inclusions that are dated at 4.56 billion years. In some other meteorites, like the Murchison meteorite that is also on display at the Louvre at the moment, another piece of our collection. This one you have probably seen in the media. It's advertised like the oldest meteorite in the world. In fact, it's of the same age as this meteorite. The age of our solar system, 4.56 billion years. But in this one as well, you find tiny, tiny grains that we call stardust and presolar grains. And these guys, they have been dated back to 7 billion years, older than our own solar systems. Well, they tell you even things that predate the formation of our own sun. But meteorite can tell you already about the composition of the solar system, how planets are differentiated, geology of the moon, Mars, and even the Earth, as I told you, and also about the origin of life. And if you look at smaller scale, it's quite amazing. You will say, okay, meteorite, now we know what they are interesting for, but how do we find them? It's like everything, usually it's not falling in your pocket like this or in your garden. I mean, you need to have a garden, of course. You have to go to hunt them. And the best way to find them is to go where they fall. It seems to be logical, but and it's to be witnessing a fall of a meteorite. A very good place is hot desert, dry desert, like Atacama Desert or Sahara. The desert around here is not so good, but there is meteorite to be found there because it's been humid and it's still humid in a way, and the meteorite have the tendency to rust. But they are quite easy to spot in the desert. You see, if you have only sand around or white stuff, a black stone is quite obvious. And why we look in desert is because they are preserved for much longer because of there is not much humidity. Another place that is mainly dedicated to scientists, it's Antarctica, where they are like preserved like in a refrigerator, and they can survive there for thousands and tens of thousands of years. And then there is even there a process because the ice is moving, and a concentration of there. It's like they are concentrated naturally. You can just pick them there. I've been myself looking at meteorite in different countries, and one of the most successful expeditions was in Egypt. I was 3 weeks going to the border with Sudan and Libya. It was before it was not possible anymore to go there. 3 weeks in the desert, in what I would call the real desert, collecting meteorites and looking around and looking at the stars. And at the time, I found half of the meteorites known from Egypt because there were nobody really looking for them. And this is one of this meteorite, and I will tell you about it a little bit later. Another way to find meteorites is to have a camera network. You know, to have camera like the one I have on the upper right part, filming the sky. And if you have several of these cameras and you film something like this, a big shooting star or a bolide, you are able to triangulate and to find out where a potential stone would have fell down. This is what I did when I was doing my postdoctorate in Canada in 2009. We were able to find this event, and we were able to map to the potential area where it would have fell. And then we went on the field and make line search, and we finally found a piece of the meteorite of Grimsby. The interest of that is that you will bring also context. You know, meteorite, we don't know from where they come from. And as a geologist, I like to know the context. In this case, you are able, because you have this camera record, you can back calculate and find out the orbit of your object and find out the journey that it had before to arrive on Earth in space. recently, I had this event taking place, November 2020, I think it was still COVID. This was recorded in Austria, seen all over Central Europe, and quite an amazing, bright event. And the next day, we were able to calculate the potential area where it fell. I don't know if you see the scale bar, 5 kilometers. The possible impact zone was huge, mountain, forest, nobody will go there. It's just crazy terrible, but did not stop me. The next day I went there, I took journalists with me, and it snowed also in between, of course, to help the search. We went there, and the idea was not to find something because it's too huge, it was to advertise it, to talk about it, and we visited the different farms and tell them, okay, this is a meteorite, please keep an eye open. And what happens, I received like thousands of emails in the next weeks and months, and one day, 8 months later, I had a phone call, somebody said, oh, I found your meteorite. I say, yes, like the thousands of the people. And he sent me a picture on WhatsApp, and I said, oh, this is really like a meteorite. And in fact, it was like a farmer that we visited that his mother on the way found this piece of meteorite. Well, we were super happy because it was a new meteorite from Austria. And then I made the classification work, I investigated it, I looked at the chemistry and so on, and then it get a name. Do anybody have an idea, like the kids, how we name a meteorite? Do we have any idea how we give a name to a meteorite? Does anyone? Yeah? This would be cool, but no, it's not. No, the name of the meteorite is after the name of the village, or the city. If I found a meteorite in Abu Dhabi, I will name it Abu Dhabi. Yeah? In this case, it's named Kinberg because it was found in the village of Kinberg. Well, every meteorite, without exception, have the name of the village. Of course, you will see sometime on my slide, Northwest Africa, NWA, like this one, is because there is many of them found in the desert and there is no village or geographical point. That's why we cannot name them like this. Because this meteorite, we investigated it, we published it. It's have an orbit, what is quite rare. There is only 50 meteorites with an orbit, and is now in display at the museum in Vienna. What is funny is that if I would not be here this week, I will be in Austria because there is a new meteorite that was just found, and that's why I'm dealing with that at the moment. Also, I'm a bit frustrated to not be in the field, but it's snowing there right now as well. When you find a meteorite, usually you cut it to see what it has inside, and you see, for example, this meteorite, it's plenty of small, shiny, silvery pieces. It's metal. And if I will put it next to water or humidity, will start to rust. It's why meteorites are really sensitive, most of them, to humidity. But in this case, I cut it, I analyze it, I put together all this information, and then it gets accepted, and then it gets a name. I suggested the name. It's this case, Great Sensi 039, because it was a 39 meteorite found in this area of Egypt. If you have a meteorite or want to know more about meteorite, there is this database that is public where you can just search like name of meteorite or type of meteorite or what meteorite have been found in the UAE and so on, or in France. It's like for meteorite to be official, it needs to be in this database. It's public, it's from the Meteorological Society. Or if you buy a meteorite, for example, you can find out there how much of this material is available and so on. But you have to find out this meteorite and know how they look like. Usually they are different from the other rock because they have nothing to do with the local geology. It's why they are odd compared to the rest. Many of them, but not all, have a density a bit higher than a normal rock due to the metal it contains, but not all of them. Of course, an iron meteorite is very heavy, 2 to 3 times more than a normal rock. If it was falling recently, it's covered with this black crust, the fusion crust. And usually they have smooth edge. They are not really sharp, but not all the time. And they are very compact. There is no vesicle inside. It's not like a French cheese. There is nothing like that. If you find something with vesicles inside, it could be a volcanic rock or a slag, what I was telling you about, this industrial product that unfortunately is everywhere. In Europe, very often people say, I found this in my garden. I say, yes, but it's anthropogenic. Say, yeah, but my grandfather, everybody I know was living here and never deal with that. But they can be 1,000-year-old, these slags. It's why you cannot know the history of your garden so well. And very often people try to put a magnet next to it because most meteorites are magnetic, but I will not recommend to do that. It's not a good test. It's also erasing part of the scientific information because the magnetic property is something we look at. And lunar and Martian meteorites, for example, are not magnetic. That's why the magnetic test is not good. The best device to use is your eyes. That's why to be trained to recognize meteorites. And when we will open our museum, you will see many meteorites that will help you to train the eyes, and also we'll organize workshop for that. Here's a small quiz. Here I have 8 objects in these showcases. This is in Vienna. I have people can try to find out if they recognize a meteorite. There is, I help you. There is 2 meteorites in there. Who of you thinks the number 1 is a meteorite? Number 2. Quite hard, huh? The thing is, on photograph, you cannot all the time say for sure. Number 3. Number 4. Number 5. Number 6. Number 7. And number 8. Okay, I saw a lot of people with number 7. You are right. It's a meteorite. It's an iron meteorite. You are correct. For the other one, there have been a few, but it's very hard to find. It's number 6. And number 6 is the one that you may find in the UAE, because this is a desert meteorite. You can see that it was lying in the sand for a long, long time, because this was below the ground, and this was at the surface. It had been sandblasted, and the brownish color is what we call desert varnish, and it's why honestly, it's difficult to find out. You cannot even say for sure this could have been a meteorite. This as well, but it's a bit sharp angle. This number 4 is a slag. It's why this, you see the small vesicle, it's hard to see on the picture. This is definitely not a meteorite. But number 1, that is a basalt. It's a terrestrial basalt. It could have been a Martian basalt or a lunar basalt. It's why it's not so easy in some cases. What I wanted to say is it's good to train yourself, but when our museum will open, or even before, we will be doing expertise of rocks and potential meteorites. Just to finish with meteorite, I had a few slides to show you quite a journey through meteorite fall. The oldest recorded fall that we know exactly on the day, month and year when it fell, it's this meteorite, so-called Nogata meteorite in Japan. And there is no typo on my slide. It was really falling on the 19th of May, 861. It's preserved in a temple, and it's written on the box that it was falling on that day. So this is the oldest recorded fall of a meteorite. Of course, there have been many meteorites falling before, and we still find them in the desert, but we don't know exactly on which day, months, and hours when they fell. One of the most famous one in terms of fall, and the most historical European fall, except this Japanese one. I mean, this one is, it fell in France in 1492. The date is quite easy to remember because Christopher Columbus was having his journey on the same year. And it was, the picture you see, I mean, it's a drawing. There is many documentation, drawing, historical art piece that features this fall of a meteorite. And in this case, it was a witness, and there is a boy that was walking in the field that saw the stone falling. I told you it's very rare. Normally you just see the fireball. And very often when you see a fireball, the thing is very far away. It's why you can see it and you say, oh, it fell after my garden, but in fact it can be 100 kilometers away. In this case, he really saw, there is description for 1492, he saw the stone falling, plunging. It was 127 kilo piece. It was chained in the church. And then it's had a long, long, long story, but if you want to hear about this story, we'll have to make another conference another day. Another French meteorite, I'm a little bit biased because I'm French, but it's because, in fact, these are French, just by chance. This one fell in 1803, and this meteorite is quite striking in the scientific community because after this fall, the scientific community agree that meteorites are objects from space that fall on the ground. The farmers and everything the people working in the field, they already understood that. But the scientists, they are doubtful and skeptic, and they did not accept this. There were a lot of different theories that it was ejected from volcano, it was a sign of God, it was a lightning. It's really this fall. It was about 2,000, 3,000 pieces that fell in this area of France, and there was a big report, and this really make scientists fully understanding or agreeing that they were objects from space. There have been, very often when you look for meteorites on the internet, they say that people have been killed by meteorite, fall and so on. There is no thing that I accept myself that is correct. There is a few reports that are doubtful, but it's not completely confirmed. At least there is one lady that had been injured by a meteorite, and what happened in this case, the meteorite crossed the ceiling of the house in the US in 1954. It rebounded on this piece of furniture, and then it touched her flank. And what you see there, she was not burned. It's like if you shock yourself, it's like this, I don't know how it's called in English, this bruise. Okay, I learned a new word. And yeah. The meteorite survived, the lady survived. This it's an interesting story, it's very well documented. This is a meteorite that killed a cow. This is not the one that is on the picture, the reconstruction. But what happens, like the guy, the farmer, it's in Venezuela, if I'm correct. He saw the fireball, and the next day he found this stone next to a dead cow. The meteorite is preserved. The cow finished on the barbecue, probably, I don't know, but at least we have no remnant part of it. This is also a very famous one. It fell on this car, and in this case, the lady was looking very unhappy, but at the end, the meteorite have more value than the car. But this car has been very famous because it has been circulating all around the world. It has been preserved. The meteorite do not exist anymore. It's existing as slice because it has been sliced. This is a piece in Vienna. It's all the time the same. Meteorites is like, I all the time say, like salami. If you want to make more money, you slice them and you sell them by slice. That's why this happens to this meteorite. One meteorite that most of you have heard, except the young audience, but in 2013, in February, 15th of February 2013, there was quite an event that was populated in the news around the world. This is filmed from a car. You see on the upper part, this is what a lot of people have seen in this part of Russia. A small asteroid, about 19 meters in size, coming through the atmosphere, exploding. And it has been quite popular because, in fact, a lot of people have been injured. About 1,500 people were injured. They were not injured because the stone was falling on their head. It's mainly because when this happened, it have exploded at a few kilometer altitude, and there was a shock wave, like a bomb, and people were injured by pieces of glass that were falling down because their windows were exploding. I've been working, I was the first team working on it. We were estimating the diameter of 90 meters. There have been very small number of stones this size. There was a big piece that was found in the lake later on, 650 kilo. But most of it have been vaporized, and in fact, the dust, you could follow the dust in the atmosphere because most of it was like turned to powder. And last story before we move to impact craters. I know I have a few slides about UAA meteorites. This one is a recent meteorite, and I found it quite cool. It was in Canada. It was witnessed. Very nice picture. Very nice shoot there. You see the bolide over there, and here you see this lady having a hole on her ceiling, and the meteorite falling over there. It fell in October 2021, and the conclusion of this story is that you better to sleep on the left side. If you look for a meteorite from the UAE, you go on this database that I told you before. You select United Arab Emirates, and you find out there is 44 meteorites that are known as of today, or that are recognized as meteorites from the UAE. This is the full list. I'm not going through this full list. It's just to say it's not many, and it's one of the tasks here that I'm starting and training my colleagues, local colleagues. We want to increase this knowledge on meteorites in the UAE, and it's part of what I'm doing today, trying to tell you what meteorites are and how important they are and why they should end up in our museum. And I'm just going to show you two of them. This is the very first described meteorite from the UAE. It was found in 2000. and somebody that was in the team finding this meteorite is even in the room, but he found the number 2. Mark is this one that he found. It's an ordinary chondrite, quite big, this size. And this was the 2 first meteorite found. He was not looking for meteorite. He was doing some archaeological survey, and they found these odd rocks that obviously look like nothing else and turned to be meteorites. There have been quite more meteorite found more recently. In 2009, by a German team that were making a dedicated search, they found 26 meteorites during these 2 weeks of search, and they are all named UIA with a number in this case. And this is why we have now 44, and I hope that in the next years we will increase this number by a few digits, hopefully. Now let's move to impact crater. What do you see on this picture? The moon? You agree? Have you seen the moon like this already? Yeah, you have good eyes because it's the far side. It's why. But it's the moon. It's the other side of the moon. And what do you see on there? Impact craters. Yeah. I like impact crater because, my teacher, when I start, they say, we don't care about impact craters, it's nothing important. But it's, in fact, the most important geological process in the solar system, and even on Earth. I will try to convince you. And on the moon, what happens is that there is no atmosphere, and everything that collides with the moon, even a tiny grain, will make an impact crater. If you collect a rock on the moon, it will be full of tiny impact craters. It's also a problem for astronauts and people that would like to live on the moon. You have to be careful because you can get quite a lot of material. Do you know what is this planet? Earth? No. Nobody get it? Mercury is Mercury. And what do you see on it? Impact craters everywhere. I'm not showing you a picture of the Earth. Sadly, I forgot to have one. But on the Earth, if you look at the Earth, you don't see any impact craters because it's not that there is no, but Earth is an active planet. It's why they are constantly erased and covered by water, covered by oceans, of course, by forests and so on. But before to go to hunt impact crater, you should find out what they are. Here, this is a model that I was developing during my PhD in the late 2008. You see the time on the top in seconds. And what you see in front of you, in 30 seconds, you have created a hole that is 10 kilometers in diameter. Well, if you don't believe that impact craters, it's a very crazy geology science. It's not something that is very slow and like sedimentation. In a few seconds or minutes, you completely change the place. In this case, I was trying to model that because I have been working on an impact crater where we have made some drillings, and I want to understand what was the journey of my rocks that I have drilled in the impact craters, where I was reconstructing the things. I had the chance to publish this as first author in Science. Probably for most of you don't make much things, but during the PhD it helped to open you some doors. And what I wanted to say, an impact craters, it's a roughly circular structure that is formed by the collision of an asteroid or a comet with a solid surface. You will see during the rest of my presentation, I'm saying impact crater or impact structure, just because I'm a scientist, I like to be clear. Everything at the beginning is an impact crater, but on Earth, due to the erosion and so on, there is no crater to be seen anymore, why we call them impact structure, usually. This is quite complex things, but I wanted to mix a little bit more advanced science here, just to explain you the process of formation of an impact crater. You have different types of impact craters. In this case, size do matter, but it starts from the same process. You have an asteroid or a comet colliding with the surface of the Earth, in this case, because we are back on Earth. And then there is a shock wave that will propagate in the ground. And then the material will be melted, shocked, and so on. And then part of it will be ejected. And depending on the size or the energy that is released, you will have what we call a simple impact crater. These are the different steps. Or a complex impact crater. We'll come to that later on. Just quickly, sorry for the kids, but what happens, the take-home message in this case is that due to this collision, you have crazy temperature and pressure that are released, and it will transform the rock in a unique way. It's a bit, at a very bigger scale, a nuclear explosion. you will transform the rocks with a high temperature and pressure in a very unique way. Some of it will stay inside the crater, or some will be ejected, in some cases 100 or 1,000 kilometers away from the impact site, depending again of the size of the things. And what happens, this is important, here I mention it, your projectile, your asteroid, whatever is the size, could be 10 kilometers. 10 kilometer asteroid will make an impact crater about 200 kilometers. There is this ratio about 20 times, 10 to 20 times. But what happens is that your projectile, the asteroid, will collide, and then it will be vaporized. That's why the asteroid, or the meteorite, if you want to say, you will not find it there. It's a bit like you are going on the scene of the crime, but there is no blood or DNA, or the murder is gone. That's why the asteroids, and this is something that people don't really think about it, except in the case of small impact crater, but if the things start to be bigger than 1-2 kilometers, you will not find any piece of the killer, in this case of the asteroid. But then you end up with a crater that is like this, is filled with rocks that fall down, and then usually when you have a hole on Earth, it's filled with water, you have some life that will develop over there and so on, and you have unique rocks. These rocks, we call them impactites. Not very difficult. Why? Because they form during an impact. And they are unique because the process is unique in terms of temperature and pressure that are generated. Again, don't be afraid. We classify things like meteorites in different, we give different names and so on, tell you a lot about the process. This was just to show you that it can get more complicated. This is to simplify the things. But in this case, what happens, the rock were there before. You know, if the things impact in a place where you have a lot of limestone, the limestone will still be there, but it will be transformed. The same if it happens in a place where you have sandstone, but the rock will be transformed. Usually you crush everything, and you make rock like this that we call breccia. Suevite, it's a very complicated term, but it's a breccia. It looks like a little bit like a piece of concrete. You have different rocks in there. Not very nicely looking, and sometimes it can be completely melted, like on the upper part of the screen there with all these vesicles. The rock was boiling. But what is very typical is such type of rocks here. You see there is this kind of pattern, conical pattern. This is a piece of limestone that have suffered this high pressure and developed this unique pattern that is so-called shader cones. And this is unique. You know, if you are walking your dog in a place and you find this on the ground, you can say, bingo, I probably found an impact crater. I'm telling you the story, but it happened once to somebody, in fact. He was just making a pee break on the side of the road and found out that there were shutter cones. This is the last complicated diagram, I'm sorry again. But here what I wanted to say is that as an impact geologist, I'm not playing in the same team or in the same league as the other, my colleague geologists. My colleague geologists, in this diagram, you have temperature here and pressure. They play in this area. This is their garden. My garden is extended much further away because of the pressure and the temperature. And it's what we call shock metamorphism. It's a process that is unique. If I find a rock that shows this evidence of shock metamorphism, I can be sure that an impact was involved to form it. The only other way is nuclear explosion. And as far as I know, we have not exploded bomb everywhere as of today. And then it's an impact that was forming these rocks. I'm not going too much into details and so on, but I wanted to give you a few facts. What is involved in this case, it's a projectile. It can have different speed depending from where it comes from, on the nature of the object. The speed of this asteroid or comets would be between 11 and 72 kilometers per second. The asteroids are not so fast than the comets, but the result at the end is that you have an impact crater. For those that like to play, I see some probably addict to computer around here. There is this link, you can take a photo probably. You can play there with a lot of parameters and try to form your own impact craters with real facts. You can put the size of the projectile, the density, if it's an iron asteroid or stony, the speed. You can put even the place and the place where you are when the impact forms, and you see how much meter of impact you will have on top of you and so on. It's, as I say, it's like a game you can play. Unfortunately, you cannot have a visualization of the things. In Vienna, I created that. You can impact Vienna, select the size of the thing, and destroy the city of Vienna. During COVID, I wanted to implement it, that you can have an embassy paying for destroying another country, but the director was not very keen. But yeah, let's look at some example. This is a picture that you see very often. It's even claimed as the biggest impact crater. In fact, it's one of the smallest, but it's very nicely preserved. And if you go to Grand Canyon, it's next to it. You should visit Meteor Crater. Meteor Crater is a small one, but it's very impressive because it's young. It's 50,000 years old. It's preserved, and it's a 1.2 kilometer. You arrive in front of a hole that is quite impressive. In this case, you see that the building was quite lucky because they just escaped to the impact. Now, it's a very nice museum that has been just renovated. That's why I really recommend you to go there in this case. In this case, we still find pieces of the projectile. You find pieces of meteorite that are a few kilos, up to 100 kilos. There is a big one on display there and in some museums around the world. In this case, it's because it's quite small and not all the asteroid was vaporized, where you can still find pieces around the things. Yeah, I show you one of the smallest preserved. This one is an impact crater that was formed in 2007. Why? Luckily, nobody was living there. But in this case, it was in Peru at quite high altitude. It's why it makes a small hole at the end, 14 meters. But we still find, in this case, pieces of meteorites. This is a piece of meteorite that was found next to it. I'm saying this is the smallest, but it's probably not existing anymore. If you go there these days, after these years, it has been completely erased. It was not preserved, I'm quite sure. But then you have bigger one. Bigger one will have a more complex structure. There is a central part. You know, the other one, they were like ball shape. And when you start to have something bigger, what happens, to simplify, because it's much more complicated, is like a rebound. That's why you have a mountain in the center. You see them nicely on the moon or other planets where there is no alteration. On Earth, the central uplift is the first thing that gets eroded. But here you see it quite nicely in Charlevoix. And they can be big. You see the impact crater over there. This one, you can see it when you fly to the US. It's in Canada. I all the time try to wake up if I sleep during this flight. I never pass exactly on top. But this one is 100 kilometers in diameter. But the circle that you see is only 60 kilometers because what you see is only this part, in fact. The rest was eroded away. There have been probably kilometers of erosion over there. And then when it gets bigger, one big one is the one on the upper right. You have all heard about the name. Is normally a test when I hire a student if he is able to say the name. Is Chicxulub. Chicxulub is in Mexico, 200 kilometers in diameter. And this one you have heard about it because it's a dino killer. And you have probably even heard more about it in the last years because we drilled it. We had a very successful drilling campaign over there, and we published really a lot of Science, Nature, and so on paper. We found a lot of things, but I'm not going to go into the details of this because it will be boring. I just want to tell you how to find an impact crater. To find an impact crater, you have to find evidence that an impact took place. And as you understood, there is high temperature, high pressure that are generated. That's why usually you are looking for this rock that I showed you before, the shader cones. If you look at the microscopic scale, you will see that the mineral will have also suffer from this pressure. In very rare cases, you can, if you find meteorites, a lot of meteorite around a hole, you can conclude that it's linked to an impact. And in some cases, you can do chemistry and find out, because I told you it's vaporized, but there is a very tiny pieces that could be mixed with the rock. And using chemistry, you can find out that an impact took place. For that, to find a new impact crater, there is no way. You have to go in the field. You have to go in the field. You have to find a target like this. This is satellite images. I will come back to that. You have to go on site and find what you have been looking for. And if you find the rock or that you are looking for, you can confirm an impact crater. This is the picture of the Earth. It's the map of the Earth, with all the red points that you see on this map are impact craters that have been confirmed. There is about 200. I'm saying about because the thing is we are revising this. I'm leading a group of scientists worldwide that under the umbrella of the Meteorological Society, we are revising, going through all the impact crater. And I say about 200 because there is a few that we will kick out because there is no good evidence or strong evidence why we are reprocessing all our data. But most of the ones that are on this map will stay as confirmed impact crater. You can see there is no in the UAE. I will probably keep my eye open, but I'm not so optimistic. There is 2 in Saudi, 3 in India, and so on. And all of those, they have been found, some of them quite recently. And I was lucky enough to found or confirm 5 of those, and I will take you to a journey for 1 of them. To search for an impact crater is a bit of a mix of Indiana Jones and Sherlock Holmes, because usually you have to go in some remote countries, and you have to keep an eye open, and you are looking for, not for DNA or blood or whatever, but you are looking for shock minerals. I'm trying to train your eyes here, like for meteorites. Probably it's a lot of information at the end, but here what you see is shatter cones. This is, both cases is a limestone, is a rock that you find quite often, but due to the impact and the shock wave propagating, it forms this very unique conical pattern. This is the only thing that if you found it during your journey, you can be sure that an impact took place. It's the only thing you can identify with your eye. Another rock you find very often in impact crater is a breccia. You see, like what I told you, a piece of concrete and so on. But in this case, I can tell you that this is formed due to an impact only if I look at it back in the laboratory. If I look back in the laboratory, I need a microscope. I cut a small slice of my rock, and I look at it in the microscope. And what I see things like this. This is a piece of sandstone. This, what you see, is quartz grain. You will find a lot. If you go in the desert, you collect sand, you make a section, it will look like this. But if this rock would have suffered an impact, it will look like that. Well, this is a unique pattern that if I find this in my microscope, I should film myself. I will be like, wow, I found a new impact crater. This, by the way, it's a new impact crater that I found there. Here is another image, and I will not go into details. If you found this in the quartz, it means that it has been exposed to pressures that are crazy high, and you cannot generate this pressure in anything else. Volcano does not make this. There is no way to produce this other than during an impact and a nuclear explosion as well. What I want to say is that not every hole that you can find around is an impact crater. It's most of the time not an impact crater. Very often you see in the news a big title, a new impact crater has been found. Most of it, you can take it and put it in fake news because most of the time it's not serious science. And you have to find proper evidences. This is one of the impact craters I found in Sweden. This is a lake that is known for a long time, and for decades and decades people were thinking it's an impact crater, but nobody found an evidence. People find rocks around like this, but by looking at it, they never found anything conclusive. But luckily, with some of my students from Sweden, we look at it, we made a thin section, and this is very important here. This is a thin section, it's like 1 inch, and you see this is a small part of the rocks that is cut and grinded down to 30 micrometer by a very expert technician. I'm thinking about the young generation here because we will be looking for these people. And this was prepared by my technician in Vienna, and you can polish a little bit more or stop and so on. And why I'm saying that is because in this section, we found this grain. And you see it has this unique pattern. Well, this is like the smoking gun. I could confirm that this is an impact crater. And this grain, I think, was here. And there was no other one to be found. So I told him, you would have polished like a few seconds more, it could have been gone. Then we published it in Geology, these things, and it was a new impact crater. But now I will take you to another journey. The last journey. I'm still on time, plus 1 minute. I will take you with me in the Democratic Republic of Congo. This is an expedition where I was trying to find out if this was an impact crater. It's 17 kilometers in diameter. It's seen on satellite images, and it's located in this lovely place in the Democratic Republic of Congo, in the Katanga, not very far from Lubumbashi, and it was Elizabethville before. And this, before to go in the field, I put together 3D models, and when you see that, this is the elevation there. You see the elevation going from about 1,000 meters to 1,700. Well, I knew when I will go there will be a little bit of hiking. And the most difficult was to reach the place. I was financed by National Geographic, like for many of my expeditions. And this is Google Earth. Google Earth is very fine. You say, okay, I want to go from Lubumbashi to the impact crater, that is possible impact crater, sorry. It says just take the National 5 and you reach the place in 1 hour and a half. The problem when you are in the field, there is no road. The National 5 is probably on Google Earth, but it was not constructed, at least at the time. And nothing really went as planned, because originally I was thinking I will be in my car and arriving here and arriving in this village, and then I could go there. In fact, the road was not finished, there was no bridge. It's why we had no choice than to take the back road. And we end up in this village, the village of Lualala, and then there was a small canyon. There was no way to go further. Well, I said, okay, let's go by foot. I was a bit pissed because the car is the most expensive thing in this expedition. And you see the only one smiling on the picture is the second guy, because he's a driver and he knew that he was going to have 1 week of holidays. And then I had a military for my safety, because it's quite a dangerous place. And I recruited local people to carry the stuff, but as you see, I was carrying more than the guy I pay for carrying the stuff. We crossed the savannah, quite fine, nice things, but then we end up with the relief and the grass. But as I wrote here, the advantage of the grass is that you cannot see the snakes, but they were like just going crazy between our legs. And I even discovered, this is the second time I was there, is this snake that have not been reported in this area of Africa, of course, because nobody had been there. And I did not know at the time, but it's one of the most poisonous snake. But don't worry, when I go like this, in this case, I took with me a PhD student from Lubumbashi and a local guys, and I'm all the time the third person. Because the first person put the leg on the snake, the second one is bitten, so you better be third. In this case, it almost happens, but what happens is that they did not put their feet and they did not sew it, and I managed to take this picture. Then we arrived in this small village, like 10 huts like this, and they were quite surprised to see me, because they told me the last person, white guy they saw, it was 30 years ago. And in the village, they were quite young people. That's why I did not stay there, because it was lunchtime. No, joking. But we continued the journey. This was a small village, Kizibwe. And then when we arrived there, I decided to take the first room in the hotel, because I was quite tired. We put a tent, and there was nothing permanent there. Installing a desk and so on. This is my PhD student at the time. And then it was quite challenging to find rocks, but we did find rocks, and what you don't see on any of my pictures is the military guy. The military guy that was here for my safety. In fact, I was putting him to protect my tent, and then we were quite free to move around. Not many animals to be there, because they have been all hunted. They were poacher things. We managed to arrive in the center of the places, and you even see on pictures, it was quite crazy, there were like black fly all around. There are even on each picture, so I was not able to get rid of those. And here you see me very happy, because on this day, on this moment, I knew that I found the first and only impact crater in Central Africa, because I found these shatter cones. Well, this was quite an amazing moment. Like my student and the local guys, they did not really understand why I was so excited about this boring rock. But at this moment, I knew that I was able to confirm the new impact crater. Back in the lab, I'm skipping a lot of steps because there was a lot of other stories. I made a scene section, look at the scene section, and what I found, shock quartz. It's why bingo, I have for sure a new impact crater. Made a nice paper in geology. It made the first line on National Geographic, and it was even more popular than the return of whatever space station was. It was really popular, they told me at the time, this discovery. And then my colleagues say, oh, you must be very happy, and move on to something else. But I'm a little bit crazy, probably. I wanted to go back. Why I wanted to go back is because I found my rocks. I knew that there was an impact crater, but I don't know how old it was. And I did not find a rock that I could date, because the rocks that I found were shocked, but not shocked enough to reset the chronometer. Well, I organized a second expedition. In this case, National Geographic did not finance me, but I found a private person that was keen enough to sponsor it. And we went back, and we found this rock. This is quite nice rock. You cannot see so much on this, but if you start to cut it and polish it, you see that there is some flow here. It means there was some melting. And this is quite interesting because it's a melted sandstone, breccia. And you see the age over there is in red. We know this is the maximum age because it's the age of the rock that we have sampled that have been impacted. And I'm not telling you, but now I have an age. It's the next paper that we will publish probably next year. We have been able to date it. It took quite a lot of time because it's very challenging. We are analyzing tiny grains, and it's very difficult to date and impact craters because the rock have already an age, and if you don't reset completely, you have a mixed age. So in this case, you have to be very careful. And what I remember this moment for is also because I celebrated my birthday. Usually I try to celebrate my birthday every 2 years in a new impact crater. And this was quite funny, some kind of champagne by plus 35 degrees after 2 weeks in the field. And then to finish, I would say, but you would say, why should we look for meteorite impact crater on Earth? And here I have some answer. So it's a big list. I don't like these things, but it's to not forget anything. Me, what motivates me is that, of course, the adventure. I love these journeys. And it's a possibility to make a new discovery. And, you know, many people think that you need to go on Mars or somewhere, but there is still a lot of things that have not been explored on the Earth, even macroscopically speaking. And, you know, we are curious. It's why to discover something, it's what excites me in a way. But, of course, when you look for funding, this is not what you are going to say because you don't work for a travel agency. It's to better understand this event because the more we know, the better we can plan in case of such an impact happens. And we can also model what happens in the past. There is an economic reason also that motivate because there is diamonds, impact diamonds, there is oil, there is gas resource in impact crater. And in fact, to better understand them, allow us also to better understand other planets because they are like windows. We can see rocks on other planets that are below and that are exposed due to impact crater. That's why you have to better understand them on Earth to understand the planets. And why we should care is because in the past and in the future, there have been and there will be new impact craters formed and collision. And here is some kind of statistic, but don't read all that. The reason why we should care is just ask the dinosaur. And I will end up not with a negative note, because all the time, you know, in the American movie, they are saying, okay, impact craters are destructive, but me, I like to see them another way. Without this impact, we will not be here probably today. It's why it's also, you know, the development of life or evolution is linked to impact crater as well. That's why I prefer to see the things on the better side. Thank you for your attention.
Wow. That was something amazing. Okay, I'm sure there is a lot of questions. Let's move the chair.
You should stay until the end of the question if you want to touch the moon.
Oh, yeah. All right. Who has the first question then for Ludovic? Sorry. Up. Okay, go ahead.
Yeah, my name is Mohammed Ran Ahmed. I am 14 and probably a lot of you know me already. Yeah, but so that I'm going to cheat a bit. I kind of have two questions.
All right,
like,
two questions.
Has there ever been a meteorite that's radioactive? And if you go back to the map of meteorite impacts, can you go back?
I will do that, yeah. Radioactive, no. Meteorites, I mean, I have been very, you know, making a general survey on meteorites. If you want to hear about meteorite, I'm going to give another talk on meteorite online on the 14th of January with the group of Alain. Brigitte? Yeah, and I will give a lecture specially on meteorites, and I will give answer to some of your questions, but I will answer you now already. Radioactive. No, meteorites are not more radioactive than normal rocks. There is no, they are not glowing in the dark. There is no risk. They are not radioactive. Well, this you find it on the internet very often. Don't trust the internet. There is no...
I don't trust the internet. I'm just wondering, because I know there's radioactive material in space.
It's good. They are not radioactive. I mean, not more radioactive than a normal rock. This you wanted to see.
Yeah, so like I see in Europe a lot of the meteorite impacts are concentrated on one specific location. Is there any reason for this, or is it just a coincidence or an anomaly? If so?
Do you have any idea?
In Europe.
Yeah, why?
Why? Basically.
You know, I like to ask you your question. What do you think?
I'm not too sure, honestly.
Like there's several reasons, in fact. The reason here, you see there is a lot in Northern Europe, there is a lot in North America, a lot in Australia, there is several things here. You have the age of the rock. If the rock is very old there, if it's like 1 billion years old, it's have suffered more impact. It's like if you look at your grandmother, she has the skin more marked than your mother, hopefully. This is the same, it's a question of aging. That's why this is one of the reasons. But you will say, okay, wait a minute. There is also very old rocks in Africa, very old rock there. It's also where people have been looking for it. A lot of people have been focusing on Australia, a lot in Europe. I discovered 2 myself in Europe, is why we have been focusing there. But there is, like this one is the one I told you about. There will be nothing if nobody will look there. I have several candidates. If you want to join me in an expedition, you just need to go there to find the evidence, to publish. It's quite a long process, but there should be normally, if the rock will have the same age, there will be everywhere impact craters the same distribution. Here you have the age of the rocks, and you have also, Earth is constantly renewed. Well, there is no in this ocean, because the oldest rocks will be 200 million years old, and it's also very difficult to find impact crater in the ocean. It's another topic. But it's based on this, and also the coverage and the alteration. To find impact crater in Brazil with this crust of alteration and the forest, it's much more difficult. But if you want to go to hunt and find new impact crater, there is a lot in Africa. There is, I know one in Yemen, but I need to be dropped with an helicopter and back after 30 minutes. But there is very many that are easy to confirm, but very dangerous to go.
Okay, so it's just because people are mainly looking there?
I mean, it's because people have been searching there as well. Yeah.
Okay, I was just wondering. I thought it might have been some kind of anomaly or something.
Anomaly? No, they fall all the time, everywhere, same.
Okay, thank you.
Thank you. Actually, I do have a question about that map. What about the Barents Sea?
In what?
The Barents Sea.
On the top, the red dot?
Yeah.
Yeah, this is one that probably will be kicked out when we will finish. To review, I mean, this was confirmed with drilling. You need a drilling.
Oh, okay.
But there is much more potential one below the ocean, but the problem is to drill and to get sample.
Okay.
Because the only way to confirm is to have a rock.
Mm-hmm.
You see very often in the news, okay, somebody see with satellite images or with geophysics or circular structure, they make it even to peer-reviewed journal and claim things, but it's not confirmed. It's like if you would, you have to have the DNA or the blood to find them. I mean, you can guess they are, but the only way is to go on site and collect rocks.
To have proof. All right, amazing. Another question? I have one here.
Mark, you don't ask question.
Yeah. Oh, yeah.
I have 2 questions.
All right, 2 questions. It's a
My first
two-part
one
question.
is, where in Canada did the golden meteorite fall?
Where can the order?
Where in Canada did the golden meteorite fall?
Golden meteorite.
Yeah, you mentioned it on the slide.
Golden, yeah. Golden meteorite, yeah, you followed quite quick. Golden is the name of the village, Golden. Why is named Golden? It's in Canada. I think it's in British Columbia, or at least in the west part of Canada. But it's not made of gold. It's named Golden because the name of the village.
My second question is, Crater Lake, is that actually a crater, or they just call it that?
Crater Lake, this is in the US?
Yes.
Yeah, it's likely a volcano.
Okay.
So it's also a crater, but there was no asteroid. It's just material just coming from below.
Okay.
There is a lot of places called crater, but most of them are volcano.
Thank you.
Thank you.
But I mean, if you have an impact crater, it will be filled with water very often. And this is very cool for people looking at sediments because it's like a trap. And you can record the climate environment. When we drill an impact crater sometime, the motivation is not to find out if it's an impact crater. This nobody will give you money for that, but is to have a record of the history and the past climate and so on. But you say, okay, we drill a little bit deeper and then we have some rocks from the impact crater.
Yeah.
Thank you.
Thank you. Can you pass on the microphone? Claudia, you had a question?
Yeah.
Oh.
Orbit from which the meteorite is coming, and I would like to know how you are doing this.
Yeah. I'm not doing this myself. It's a teamwork all the time. In this network that I have been setting up one in Austria, we are working on. There is already one in the UAE with 3 cameras, but we will work with the people from Sharjah that are leading that. The thing is, if you need at least 2-3 cameras to film an object. You have the path, the bright path that is recorded from 100 kilometer altitude to 20 kilometer altitude. If you are able to make the record of this with at least 3 cameras, by triangulation, you can recalculate the journey it had before to enter the atmosphere. Okay. And quite precisely, and this has been done so far for, I think now we are around 55 meteorites only. And there is more and more because now we have a lot of this camera network. Another way, there have been 4 of this event. The asteroid that gave birth to a meteorite was detected in space. You have probably heard recently, the last one that happened was in Germany. It was detected by a telescope before it arrived in the atmosphere. And in this case, we have even better orbital data. And we can track it back to the... Of course, we cannot track it back for hundreds of million years because probably the asteroid was not stable. But these are my colleagues from astronomy that do such type of calculation. It's a bit complicated, but they reach good agreement. They can track them back to the family of asteroids. And this is very interesting because we have the meteorite on the ground, and we can, there is a classification of asteroids, and we can then have a unique object from this family and better understand by coupling this observation with astronomical data. It's getting very exciting.
Wow, that's really interesting.
But me, I'm not doing this calculation. My expertise is really on this shock quartz. I'm looking at other minerals, but really these things. But we are collaborating with people and developing this expertise in the UAE. For example, in Sharjah, they are very interested by doing that. And I will let them develop this here. I will prefer to go to hunt for the meteorites.
Oh, cool. Thank you.
And, well, a question about the asteroids in orbits.
Yeah.
What is the chance for all that train of asteroids to just deviate from that orbit and end up
there is different classification of asteroids. There is some of them that we know that they will at some point cross the orbit of Earth, and those ones don't get a name like me because you cannot have an asteroid that is potentially going to impact the Earth with a name. You imagine Ludovic Ferriere is going to impact. But this is a constant movement, but it's quite stable, and we know. There's programs that have been mapping the bigger one. But there is still many that we don't know. It's why sometimes we have some that you probably hear in the news, like an asteroid just passed by close or just burnt into the atmosphere. There will be more and more, and there is more and more of this event because we look at smaller ones. Like the one that happened in Germany, it was earlier this year, no, last year. I'm a bit confused now which year we are. But I remember I was coming back from a reception, and I was at home, and I received a message, asteroid going to impact between Finland and Austria in 45 minutes. And I was really exhausted. It was just before to come here. It was in 2024. And I was like, I hope it's not going to fall in Austria. Because I could not have come here. It would have been crazy. And finally, the next day in the morning, I saw, it was falling next to Berlin. And I was like, whew. Because when such things happen, I will fall as well. Yeah. But there is big programs now of telescope. Even there is amateurs that are involved in this case to map the potential asteroids. And you have probably heard, I did not cover that because it would be like 5 hours conference, but there is this DART mission that have been also testing the method to deviate this asteroid. And we have organized a big conference like this in Vienna, and I was like telling them, we should not deviate all of them because I want impact craters to form on Earth.
Of course. We have a lot of questions over there. Yes. You had the microphone? No, you don't have it anymore. Oh.
Yes, I have some questions. The first one is, I want to know what is the country that has recorded the highest number of impact craters The second question is, as you went to Louise, I'm from the DRC.
Oh, okay.
Yes. So you said that
Louis, should be Louis even.
Louise.
Yeah.
Yes. You did not reach the Louise impact structure. So I want to know, do you plan to go back there to organize an expedition or?
I think you have a volunteer here.
The first one, the country where there is most impact crater, it might be Australia, I would think. North America, I'm not sure. There is a count there. It's North America, but Canada have a lot. So I would guess it's between Australia and US where there is the most impact crater.
Okay.
But it's of course depending on the size of the country and how there is a big potential in Russia. Of course, it's not really as easy these days, but yeah. And about Louise, I have been there. I've been 2 times in the impact crater in the Louise. I don't know if you are from this part of DRC, Congo, from the Katanga. From where? Kinshasa. Yeah, I've been as well, but this is another expedition. And I have been twice there. I don't need to go back. I would love to collect more rocks, but yeah, I move on to something else. Last time I went, the second time I bring some students with me, but I mean they did not continue in this field because it does not generate much money. But in the Congo, I have another expedition that I have not been talking about. I went in the very center of Congo, next to Kindu. I don't know if you see Kindu in the Ready Center. After 2 days through the jungle with motorbikes, and in this case I did not find any evidence for an impact. I believe it's an impact crater, but it was a crazy story. I can give another lecture about that. I collected a lot of information about the plants and especially the animals, because I was not able to find rocks. It was quite frustrating after such a long journey, and it was quite a journey because the airplane crashed, even the one I should have taken. It was, but there is potential in the DRC, at least for that one, but we need to make a drilling. And I mean, there, where it is located, would be very costly. Yeah.
Amazing. I see a question here.
But the potential to find new impact crater in Africa is quite huge. I have many candidates, but it's quite hard to reach them, or is in situations that are very difficult, especially for a French white guy to go there. Yeah.
Yes.
Yeah.
Hi. So I actually have 3 questions, but maybe the third question would be a little bit too long. So my first question is, I remember the Swedish rock. How come that some rocks have like multicoloration?
Oh, okay. Is this the greenish one that you have seen from Sweden?
Yeah, but also some others that had like some multicoloration
the color of rocks will depends on the minerals. You know, a rock is many minerals that are put together, and it will, for example, for that one, it's kind of a piece of a granite, and usually granite are more whitish, grayish, pinkish. But if you have some iron that is penetrating in the cracks and oxidizing or reducing, it will change the color. It's depending on the chemistry, generally for a rock. But you can have like rainbow colors. Even a simple rock like a sandstone that is made purely of quartz grain, if you have in the matrix some different oxidation and reduction, you can already have a rainbow of colors. Yeah.
Okay. My second.
But you are probably talking about my things seen through the microscope, Ferriere. Like in the microscope, when you look at it in the microscope, what happens is that it's a polarization of the light, and this probably is a bit too complicated for now, but it's a little bit like, you know, I don't know if you make photography, if you put filter, and depending how you, the light is white, right? But it's made of all the rainbow colors, and depending, you can reveal all the color of the rainbow.
Yeah. Okay.
I'm not the best one to explain this. It's physics, but ask your physics teacher.
My second question is, where do meteorites like come from space?
Yeah, meteorites come from space. Yeah, I mean, most of the meteorites, they come from asteroid belt between Mars and Jupiter, some from Mars, from the moon, and I will answer another question you did not ask. is there any meteorite from outside the solar system? It's probably, you have probably heard in the news recently there was, recently, it's already a few years ago, there was like a cigar-shaped asteroid that was passing and going away that was potentially coming from another solar system, or if you believe it was another type of life form. But in fact, there is potentially, and possibly we have some in collection, we don't know, or some need to be collected, rocks that come from outside the solar system, you know. Wow. And you know, like now I tell you, these are meteorites. If you look 200 years ago, we did not know about them. Like 30 years ago, we did not know that we have lunar meteorites. Martian meteorite is why it could be we have some odd rocks that could come from something else. It's very hard to find meteorite from Mercury. There is some people claiming that, but it's too close from the sun. It will be ejected from Mercury and end up in the sun. Venus is almost impossible due to the atmosphere. But the problem is, you know, we have some meteorite, we don't know really from where they are, but it's different. It's very difficult to scientifically say they are from there because we don't have the data to fit with. Yeah. Your third question was?
Yeah,
that will be the. Go ahead. That will be, I think, the last one from the night. So go ahead.
And my last question is, how, like, could you explain in specifics how an impact crater is created, or if an impact crater could be like, could it be bad for like planet Earth?
Yeah, I mean, an impact crater could be pretty bad. Yeah, I mean, like if you see the dinosaur, like 66 million years ago, there was this asteroid about 12 kilometers in size that collided with Earth in what is now Yucatan in Mexico, make an impact crater 200 kilometers in diameter. It had a lot of consequences: earthquake, tsunami, nuclear winter, meaning that it was for decades dark and so on. And this was very bad for a lot of species. It's why it can be very damageful in a way. And I mean, if you want to know more, come to visit us next year. We will develop this topic at the museum, and we'll have a workshop and a lot of things related to that. But it can be very bad. But as I say, you know, I like to see the life in the other way. It can be very good as well, because you know, if we would, if we are here today, and if you believe this theory or these things, like if the dinosaur would not have been exterminated or the other species, the mammal would not have developed as they have developed today. That's why it's a positive way of seeing this bad event in a way. Now these days, yes, there is this, I mean, the big one, hopefully we will detect them early enough and we can redirect them to another country, not to redirect them somewhere else. And there is a new book that was just published on that, and I think I have been interviewing this book. I have not read it, it just went in print a few weeks ago from a British author. That is, the title is quite funny. He's explaining all that very nicely about potential asteroid colliding with Earth and the different ways scientists have been developing to change the orbit. Yeah.
Amazing.
Okay, thank you.
Thank you.
Touch the moon. Or I should go out there for everyone to touch it? Or?
Yeah, or they can come to us. I'm sorry, we'll have to come over and ask the question to Ludovic directly. I think you have a bit of time. People will come to us. Thank you so much for coming. We will see you. Actually, I wanted to say something. If you can just put, if somebody is here to put a picture lecture. Just here. Oh, yes, we're here all weekend at the Abu Dhabi International Boat Show. So I would recommend everyone to go over there and come and see the team. We have a stand over there. In the meantime, thank you very much and see you next month.